Hi everyone, so today I'll be going through the recursion and financial modeling section of the 2021 for the Maths Exam 1, Northern Hemisphere. Question 17, the graph above could represent the value of the balance of a saving account earning simple interest. That is correct. This is because you should know that the formula for a simple interest is Vn equals V0, and in this case plus D, because we can see that there's an increase in the value each year. So this plus D represents that there would be a set amount increasing each year. So it would be the same amount increase after each year. As we can see here, there's the same increase in the amount of the value each year because it's increasing by the same amount each year. As we can see, there's a linear increase. So therefore, that'd be simple interest. So therefore, A is the correct answer. Let's just go through the other options. So for B, an asset as it depreciates using the flat rate method, this is incorrect because a flat rate method would have a decrease by a set amount each year, which is not the case in the graph above, so therefore B is incorrect. C, a perpetuity earning compound interest, that is incorrect because a perpetuity would have the same value after each year, so therefore C is incorrect. D, an annuity from which equal regular payments are withdrawn, that's also incorrect because you should know that an annuity should look something like this. The graph should look something like that. That's because we're taking out the interest earned plus extra money money that's in the account. So therefore it decreased like this, and you should just know that that would be a graph that is modeled similar to an annuity. So therefore D is incorrect. E, a reducing balance loan with interest only repayments. That is incorrect because reducing an interest-only loan would have the same amount after each year. The value would be the same amount after each year, which is not the case in the graph above, so therefore E is incorrect. Question 18, the value of an investment in dollars after n years, Vn can be modeled by the recurrence relation shown below. This investment earned interest at the rate of 5% per annum, compounding quarterly. What is the value of R in this recurrence relation? So this question was actually invalidated, and I think that's because over here it says after n years, even though it should say n quarters, and that's because over here it says that the investment earns compound interest at the rate of 5% per annum, compounding quarterly. So therefore it should be after n quarters. But if we were to say that the question had said after n quarters over here, then to find the value of R, it'd equal 1 plus, because we have compound interest, so therefore we use plus. So 1 plus R on P divided by 100. So little r is the annual interest rate and P is the compounding period. So therefore R equals 1 plus little r, so 5% per annum, on P, compounding quarterly, on 100. Enter that into your calculator and you get 1.0125. So therefore C is the correct answer. Question 19, the value of a computer purchased for $5,000 is depreciated by 10% per annum using the reducing balance method. Recursive calculations can determine the value of the computer after n years, Vn. Which of one of the following recursive calculations is not correct? So first of all, we need to determine what the recurrence relation is. So we know that the initial value is 5,000, so V0 equals $5,000, and comma Vn plus 1 equals R times Vn, and you know that because we have reducing balance method, so therefore you should know that the reducing balance method follows this rule over here. So the value of R would be R equals 1 plus or minus R on P on 100. In this case, we're using minus because it's reducing balance method, so therefore minus, and the compound, and then we'll just substitute the values in the equation. So 1 minus R is 10% per annum, so you write 10, and the compounding periods is 1 because it's calculated annually after n years, so on 1 on 100. So do that in your calculator, you'll get 0.9, so therefore we know the value of R is 0.9. So therefore now we can determine which one of the following recursive calculations is not correct. We know A is correct because, as we can see here, the initial value is 5,000, so therefore A is correct. B, so to determine what the value of V1 is, we know that we use the value of the previous year, so the value would be 0.9 the value of V1 would be 0.9 times the previous value, which is V0, and we know that V0 is 5,000 from this over here, so therefore times 5,000. So therefore B is also a correct recursive calculation. V2 would be found by doing 0.9 times the value of V1. If you do this on your calculator, which is V1, you will get 4,500. So 4,500. So therefore, C is also correct. So to find V3, we can do 0.9 times the value of V2. If you do this on your calculator, you'll get the value of V2. So V2 equals 4,005. Try 4,050. So therefore, we can see here that this shows 0.9 times 4,000. So therefore, D is the incorrect recursive calculation. Question 20, Leonard has invested an amount of money in a perpetuity. Perpetuity earns interest at the rate of 4.8% per annum. Interest is calculated and paid monthly. If Leonard receives $1,600 per month from the perpetuity, the amount he has invested is... So to do this question, you would use the formula D equals R on 100, P on 100 times V0, where D is the amount Leonard receives. R, little r, is the percentage interest rate per annum, and P is the compounding periods. V0 would be the amount Leonard has invested. And you know that's just a formula because perpetuity only earns interest, so the amount of money Leonard would be receiving is the amount of interest he gets from his investment. So therefore, that's how you know it's this formula. So therefore, we know Leonard receives $1,600 per month. And sub R, we know 4.8% per annum on compounding periods, interest calculated and paid monthly. So therefore, P is 12 on 100 times V0, and therefore do that on your calculator, and you will get the amount of money that Leonard has invested. Therefore, you get V0 equals 400,000. So therefore, D is the correct answer. Question 21. Durga invests $250,000 in an account that pays interest at the rate of 3% per annum, compounding monthly. He makes additional payments of $250 each month into his account. The value of Durga's account in dollars after n months VN can be modeled by the recurrence relation shown below. The balance of Durga's account first exceeds $500,000 at the end of the year. Well, so we need to determine that. And to be honest, I think the recurrence relation is a bit of a distractor here, because you wouldn't really use it to find when the balance first exceeds 500,000. I would use the financial solver on your calculator. So we know that Durga invests $250,000 into the account. So $250,000 is negative 250 in the present value, because he's investing this money. So therefore it's negative. Account based interest at the rate of 3% per annum. So therefore enter 3 over here. And compounding monthly, therefore 12 for PPY and CPY. He makes additional payments of $250 each month into his account. So $250 into his account is negative $250. And so we know that the future value would be $500,000, because we want to find when it first exceeds that. So $500,000, and that will give us the value of n. So if you do it on your finance solver, you get 215.86798, and that is in months. So to do this question, to find after how many years, you round it to the nearest whole month. So 216, and you divide it by 12, because there's 12 months each year, and if you do that, you'll get 18. So therefore, it first exceeds his account after 18 years. So therefore, B is the correct answer. Question 22. Sherry has purchased a boat for $90,000. she depreciates the value of her boat using the reducing balance method. For the first 2 years, the reducing balance depreciation, the annual depreciation rate was 15%. Cherry then charged the annual depreciation rate to D%. After 3 more years of reducing balance depreciation, the value of the boat is $43,561.67. The change depreciation rate D% is closest to. So, to this question, we'll just form a recurrent relation for the first 2 years, and we know that it's a reducing balance method of depreciation. So therefore, the formula will be V0 equals Vn plus 1 equals R times Vn. So we know that the boat was $90,000, so therefore our initial value is 90,000, and the value of R is equal to 1 plus or minus R on P on 100. So you should just have that rule in your notes. And we know that the annual, and in this case it's going to be minus. We're going to be using minus because it says here that we're using the reducing balance method of depreciation, and you should know that that means we're using a minus. So the annual depreciation rate was 15%, so therefore you sub 15% over here, and the compounding periods was annually, so therefore P is 1. Do that on your calculator and you'll get 0.85. So therefore the value of R is 0.85, so we can place the value of R with 0.85. So now we can calculate the value after 2 years by converting this relation over here into an nth term relation. So an nth term relation would just be Vn equals Rn times V0. So you should have that in your notes. So Vn equals R. The value of R, as we've found, is 0.85. 0.85 the power of n times V0. And we want to find, it says the first 2 years the reducing balance was 15%, which is for the rule we've calculated over here. So therefore we can find V2, which is the value of her boat after 2 years. So therefore sub n is 2, and if you do that on your calculator, 0.85 to the power of 2 times V0, which is sorry, I should sub the value of V0 is 90,000, because that is the initial value of her boat. So do that on your calculator. And you get $65,025. So therefore, the next step is to determine, it says we've got to find the value of D now. So after 3 more years of the reducing balance depreciation, the value of the boat is $443,561.67. So that's basically saying if we had an nth term relation, Vn equals Rn times V0, it's basically saying that after 3 years, so when you sub the value of n is 3, when n equals 3, basically saying when n equals 3, the value of Vn is 43561.67. I don't know if that's a bit confusing, but if you were to say 43561.67, we're just subbing Vn, that's the value of Vn after 3 years. So we're subbing the value of V3. My bad, because that we know that the value 3 years after is 43,561.67. So sub that into the equation. So the value after 3 years equals the value of R, which is what we don't know, to the power of n. So n is 3 times V0. And you should know that the formula for R, like I showed before, is R equals 1 plus or minus. In this case, it's reducing balance depreciation, so therefore it's a minus. 1 minus R, which is the value of D, because that's the value of R is the annual rate of depreciation. So we can sub that as D if you want on 100. It should be on P, but in this case, P is 1 because it's annual rate of depreciation. So therefore, the value of P is 1. So therefore, that would be the value of R. So if you were to write that out 643,561.67 equals, sub the value of R1 minus D on 1 on 100 to the power of 3 times V0. We know that V0 is equal to the value of V2, because this equation is basically saying after 3 years from this 2 years over here that we found. So 65025 over here, and then you can just solve on your calculator, menu 3-1 if you're on a CAS calculator, to find the value of D. So I'll just write here menu 3-1 to get solved, and solve it on your calculator to find D. So therefore D equals 12.4999, which is closest to this value over here. So therefore the value of D is 12.5%. Question 23. Annie has taken out a personal loan of $5,000. Interest for this loan compounds quarterly and he makes no repayments. After 1 year, she owes $5,325.14. The effective annual interest for the first year of Annie's loan is closest to. So to do this question, we first need to find the annual interest rate, and then we can find the effective annual interest rate. So we know Annie takes out a loan of $5,000, so that's 5,000, and it's positive because it's money she has. Interest for this loan compounds quarterly, so therefore PPY CPY is 4 because there's 4 quarters every year. Annie makes no repayments, so therefore the payments are 0. After 1 year, she owes $5,325.14. So therefore, after one year, it's 5,325.14, and it's negative because this is money she has to pay back to the bank, or how much she has to pay back to wherever she took the money from. So then we can find the interest. So put that on your calculator, and you'll get 6.34998. That's the annual interest rate. Now to find the effective annual interest rate, if you got a CAS calculator, you go menu 852. So once you got that, you'll get something like this, and you just got to enter the annual interest rate over here. So you write 6.34998, comma 4, which is your compounding period. Hit enter, and you'll get 6.5028, which is 6.50 to 2 decimal places. So therefore C is the correct answer. Question 24. Vittorio has borrowed $40,000 to go on a holiday. Interest on the loan is charged at the rate of 8.3% per annum, compounding monthly. Vittorio intends to repay the loan over 4 years with 48 monthly repayments. After 47 equal repayments of $982.16, he finds that a small adjustment to the final repayment is required to fully repay the loan to the nearest cent. Compared to the 47 earlier repayments, the final repayment will be. So the first step is to use a financial solver on your calculator. So we know that Vittorio has borrowed $40,000 to go on holiday. So borrowed is 40,000 at the present value, and it's positive because this is money he has. Interest on the loan is charged at the rate of 8.3% per annum, compounding monthly. So therefore PPY is 12 because there's 12 months in a year. Vittorio intends to repay the loan over 4 years. So over 4 years with 48 monthly repayments. So we've got to keep this in mind while we calculating future steps. After 47 equal repayments of $982.16. So after 47 repayments, and the repayments are $982.16. So therefore negative. This is money he has to pay back to the bank, or back to whoever he borrowed his money from. 982.16. And the future value, he finds that the small adjustment to the final repayment is required to fully repay the loan. So basically hit enter on your calculator, and you get the future value, which is the value of his loan after 47 repayments. And if you do that, you'll get 975.386 386, and that is how much money is remaining. And we know that after 48 monthly repayments, the loan will be 0, so he would fully repay the loan. So that means if we convert this to the present value over here, if we move it to the present value, this is how much he has, $975.386, and he still has to pay this back to the bank. And we know that after an extra one more repayment, the value of the loan will be 0, because this is the value after 47 monthly repayments. So after 48 monthly repayments is from the 47th repayment to the 48th repayment, which is basically one repayment in between them until the loan becomes 0. So we have to find out what the payments are. We know that it's still compounding monthly, and the interest rate is still 8.3% per annum, and our future value is 0, so we just got to find the payment right now. So if you do that in your calculator, you get negative 9.821324. So now we can calculate the difference between the 47 previous repayments and the last repayment he has to make. So we know that over here, this was how much he was paying each month, and this is the final repayment. So therefore the difference would be 982.16 minus 982.13. Do that on your calculator, you will get 0.03. So therefore we know that the new repayments are $0.03 less. Sorry, that's rounded to decimal places, but it should be 0.02757. And then when you round it to two decimal places, it's 0.03, because all the answers are rounded to two decimal places. So therefore, our new repayment is 3 cents less than the previous repayment, as we can see. So therefore, B is the correct answer.